Kia ora koutou. This video is question 2E from this year's integration paper. So this starts off where we've got a cylindrical tank of height 150 centimetres and it's full of oil. So when I read that, I kind of think this question could actually be really quite tricky, but it turns out that it is a pretty straightforward differential equations question. We've got the tank and it starts to leak out of a hole in its side. Now there's no diagram and you hardly even need one, but I'll do one. So here's our cylinder and we know that the height is equal to 150 centimetres and it's full up to start with. So somewhere on here there is a leak in the tank. I'm guessing actually the leak probably needs to be near the bottom, otherwise, you know, eventually we're going to end up with the oil not leaking. And we've given this differential equation for dH by dt. The first thing I'm going to do is I'm going to rewrite that without the surd notation, and then I'm going to separate the variables. What we have to figure out is how long it takes for the oil to be down to 15 centimetres above the bottom of the tank. So I'm going to solve this problem, which is all you needed to do in the exam, but then I'm also going to get an expression for H explicitly, and then I'm going to use GeoGebra to graph it just to show you why our answer kind of makes sense. Okay, so starting off, we've got this. We've got dH by dt is equal to negative 1/4 times this. So this is h minus 6 to the power of 3/2. I want to separate the variables, so I'm going to leave this sitting here with the t, and this stuff has got h in it. So it'll be 1 over h minus 6 to the power of 3/2 dH is equal to negative 1/4 dt. And I'm going to integrate both sides with respect to h and t. So I'm going to rewrite this as h minus 6 to the negative 3/2 dH, which is equal to negative 1/4 t plus c. Now, it's pretty easy to muck up this integral if you're half asleep, which is what I did the first time I went through this. So just be careful that it's going to be h minus 6 to the power of negative 1/2, and I have to times out the reciprocal of that, so negative 2 times that. And just check back before you go any further that when you differentiate this, you will get back to that. And you can see that you will, because you're going to have the negative 1/2 times by the negative 2, and you've got no chain rule stuff going on with that inside term. So that's looking fine. And here we've got negative 1/4 t plus c. Now, if you're watching this video and it's the end of the year, I'm assuming that you completely understand that we don't have to have a constant of integration on both sides. And so that's why on this side, I've just got that one term there. At this stage, we can substitute in the point that we know, which is that when t is 0, h is equal to 150. That gives us this, negative 2 over the square root of 150 minus 6 is equal to 0 plus c. And we should like this because we can see we've got a square in here. We've got negative 2 over the square root of 144, which is 12. And that works out to be c. So c is equal to negative 1/6. So we're just about there. We get negative 2 over the square root of h minus 6 is equal to negative 1/4 t minus 1/6. And we're asked when is h equal to 15. So I don't need to rearrange this and make h the subject, right? I'm just asked how long does it take for the height to be 15 centimetres. Substituting in, what am I looking for? Well, I'm going to substitute in 15 for h. And again, you can see a square coming out here. So we have negative 2 over the square root of 9, which is 3. I don't know why I haven't times everything through by negative 1. I'm going to do that in a second. So I've got minus 1/6 there. So 2/3 is equal to 1/4 t plus 1/6. That gives me 2/3 minus 1/6 is equal to 1/4 t. Common denominator here, I know you're doing this on your calculator, but please don't make me cry. 4 sixths take away 1 is equal to 1/4 t. That leaves me with 1/2 is equal to 1/4 t. So t is equal to 4/2, which is 2 minutes. And we might as well answer that with a nice sentence in context. There you go. So it takes 2 minutes for the oil to be 15 centimeters. Don't stop watching yet, guys. I want to show you this GeoGebra thing. So that's the answer to that one. So now what I did is I did a little bit of extra work, which was that I went back up to here and I've rearranged this to get an expression for h. So 2 over root h minus 6 is equal to 1/4 t plus 1/6. That's just timesing all of it through by -1. Let's rearrange. So on this side here, we've got 1/4 is, so that's 3t plus 2 over 12. Let's cross multiply. We get 24. I'll just do it in one go. So I'm assuming if you've got to the end and you're still watching, you're probably pretty good with algebraic fractions. 24 over 3t plus 2 is equal to root h minus 6. Now I'm going to square both sides. So we get an explicit expression for h, which is 576 over this plus 6. So this is kind of interesting because I just chucked it into GeoGebra and I didn't put any restrictions on t. So you get some funny stuff going on, but this is what it looks like, and it lets us see that we've got the right answer. Right, so if I'd done this before if you're in my 13 MCA class, if I'd done this before I'd put up the first lot of work solutions where I had t equal to 1, I wouldn't have made that mistake. But you can see that what I've put into the recording here is just half of this graph. So it's also got, in theory, it's got a negative branch, right, with t negative, but we're not interested in that. What we can see here is we can see the intercept at 150. So when the leak starts, the height is 150, the tank is full, and you've got this decline process, which isn't exponential. It's kind of an inverse quadratic-y thing. But most importantly, where is it 15? Here's 15 here, and it is happening after 2 minutes. So there you go. Again, I think that's a pretty easy excellence question this year for the integration one. Interested to know what you guys think who actually said it. If you want to leave some comments, that's fine. And I'm going to do question 3E probably tomorrow morning. I'm kind of surprised that people are watching these, but a few of you are. So please do let me know if there are any other questions in the paper that you weren't sure about apart from the excellence ones.